right? So um, now before we start the class, there are some administrative issue that I have not posted any announcement on the Canvas yet, but there are a lot of new information already on Canvas, including your midterm exam and some information about assignment number 5. So basically, there are two sets of solution. I'll call it solution set that has been posted to module number 3. So if you go into module number 3, I have one document. I think it's called a assignment 5 grading notes, or assignment 5 grading note. Let's take a look at where they are. So assignment 5 grading notes. Right. Oh, this section is missing one document, but the second one is called MIS 542 select -2 supplementary, right? This supplementary is a document that I have used the information that has not been introduced, but the other one, and I'll try to make it available to this particular section soon. But the other document says MIS 542 assignment 5 grading notes or select 2 grading notes. One of those documents is the basically using the subquery that you have learned to come up with a good report without using other fancy concept or tool. And this one, I'll come back next week and we will discuss this select 2 supplementary a little bit. The reason being that in this particular document, I use an object or concept called view or database view. So far we have learned some of the database object. In the first object we learned is called table. So when you recreate all these data, you are using the table that in the data set. But what we are doing here is that we use another concept called view. And view is simply saying that without further defining, it's a virtual table. So it's a temporary table of some kind. And the definition of the textbook tells us it's a dynamic table. So it can be treated as a table, but in the assignment, the role is to use the view as the intermediate calculation step, right? Because I believe a lot of you, when you are struggling with assignment 5 query, you find that, well, it seemed like a programming assignment already, because what you need to do is you need to have some step to achieve the format that you want to get. So this is using the concept of view, create multiple steps to achieve the purpose of coding. And of course, after we come back from the exam, the next step is that there is something called a database programming. So you can actually write SQL statement into we call them store procedure, and or trigger, then one of those static programming block that you can reuse. And that is very similar to traditional programming, but a little bit easier than traditional programming. And our class, of course, is not a computer science class. We're not teaching you programming, but at least that in the future, when you see that kind of a store procedure, you can understand what they're trying to achieve or do, right? So that's our goal. And that concept of view and some other database object that we have seen from the object browser or from SQL developer, when you expand the table, then there are a lot of objects. We will discuss those after we have entered the second half of our class. So in module number 3, which is where we are right now, and there is a video that I think very similar to what we're going to be doing today, but probably different, because every semester I try to approach the same problem. I think differently, so I don't know which one is better, which way is better, and I think this one, the thing we're doing today is better way of understanding ER diagram, right? So every semester I kind of improve from my previous lecture. A long time ago, it was very long lecture, like 2 hours lecture building the ER diagram, but I kind of try to compress them into 1 hour, maybe hour and a half, like what we're going to be doing today, right? So that's what we have. So to work on that, we have to look at assignment first, right? So very quickly, I will go into assignment number 7. And assignment 7, it looked like a very short assignment, right? So the statement here is very short. It's kind of, a case description is about a business situation, right? And it's borrowed from Dr. Dinesh Batra, and he was my faculty mentor when I was kind of new young professor. I think he retired already in recent year. I haven't talked to him for probably 4 or 5 years, but um, and he and I, well, actually, he mainly worked on the a database book, and so and come up with this particular case and help, and I help to modify every semester to give it a different flavor every semester, so a student cannot copy the answer. So basically, what I do every, well, not anymore. But this is I've been using the case for about 3 years. I haven't changed that. But usually, well, the reason being that we don't have many students in the last 3 years due to the pandemic. But usually, I change some of the requirement in the case description. Say, for example, in the second paragraph of the case, you see that we are trying to record information about marriage. If there's some employee, they're couples, so we want to know they are a couple working in the organization, which is, in organization management is very important, right? So sometimes I change that into, instead of marriage, I would say, so their income level, low income level, middle income, and so on and so forth, and change some of those or to give you a different, give student a different way of working on the case. So the company, the fake company is called Project Inks, right? So the idea is that we are going to be creating a problem that is complicated enough. Actually, this is probably among all the database textbook, this is the most complicated case in ER model. ER model. So talking about ER model, entity relationship diagram, many of you have learned it before, right? And my job here in a graduate level course is I'll help you to unlearn it and learn it again, right? So you're going to be learning the ER diagram in a different way. How many of you have learned ER diagram before? Entity relationship diagram. Okay, 2, 3, half of you, right? So for those of you who are new, which is fine, we're going to be helping you learn new stuff. But if you have learned that, you need to forget a little bit about what your professor tell you how to start a ER diagram, right? The reason being, in at the beginning of our you can say the discipline, database discipline, and ER diagram, and or data model in general, right? Data model is a bigger bracket, right? Terminology describing use a diagram, or even not, sometimes not even a diagram, sometimes just description, right? Write down, okay, what do I need for the database? That's a data model, right? So we build a model before we actually build a database, right? So it's kind of like draw a blueprint. You draw a blueprint, then you build the house, the building, and we draw a model. Then before we actually build a database, right? So the original purpose is for that. And if you read the textbook in detail, you'll find that chapter 5, chapter 6, at the beginning, they will tell you these two chapters are assuming you are designing a new database, right? If you go into chapter 3 and 4, if you recall that last week we talked about normalization. Normalization is the idea, originally also a way of organizing structured data before you build a database. But the textbook approach normalization, assuming that you already have some data sitting around and you want to reorganize them, right? So the purpose of normalization from the textbook's perspective is to reorganize the data into a more structured way, so you can protect the integrity of the data, reduce the redundancy of the data, right? So those are the two main purpose of normalization. So one is revise, restructure The other is design new, right? But nowadays, in our computing environment, the chance for you, for anyone, including you and me, to build a new database working in a corporate environment is almost zero. You're not going to be build a database from ground up, right? So build an entire new system. No, most likely you will be using a system already. Say, for example, enterprise system, SAP, PeopleSoft, or a small company use QuickBook, right? So, and the QuickBook has already a database, right? So your job is not to build a database for QuickBook. Instead, you have the QuickBook, you want to grab the data out so you can do reporting and analysis and so on and so forth. But unfortunately, that these commercial software, they don't tell you what the data look like in their system, right? They will probably give you some like a user manual or charge you in consulting fee if you need to grab data from their system. You have to ask them, okay, I want to have the past 3 years of transaction in the Springfield location and the mail only, and so they can grab the data and they will charge you, or you will find a way um, to access the database yourself because the database is yours. You own the database, right? And that is when the normalization and ER diagram in particular will help. And most of the database today has a feature of reverse engineering. Reverse engineering means that you have something out there. You can actually use a program to look at what the table look like. All right, so what the table relationship look like in the database, and that usually is a story in the form very similar to ER diagram. So understanding ER diagram help you to understand database better. Right? So that is well the reason that you still need to learn ER diagram, right? But just as I mentioned before, my job is to help you unlearn it because in the past you learned ER diagram to design database. Now I want to use ER diagram to help you understand data structure, database, and so on and so forth. So to do that, we are not going to be starting from scratch and teach you this is entity, this is attribute, this is how we do that. Instead, I'm going to be jumping into a few interesting stuff. Right. First of all, yeah, to me that's interesting. I don't know about your perception, but it's interesting to me. First of all, let me open up chapter 5. So our lecture today is mainly based on chapter 5 slide. Right. So let me jump to the correct, right. Right. So jump to this particular slide first, and to tell you one important thing, right? I think in week 1, I sort of throw a lot of this jargon to you, say schema, connections, and you have to do this, do that, and this is actually you can call a schema. Right? So anything used to define a database is a schema. Is a schema, and in some situations, schema will be used as a user data. If you're a user account, then you log into account. That entire database you are using is also schema. But anyway, so but you know the meaning is actually talking about definition of database, right? So this is the way of defining database, and it's a ER diagram way of defining database. And what it seems very simple. On the top, it says, okay, we can define a entity based on the real world data object, right? So because we need to record customer information, so we create a customer entity, and that in chapter 6 will be converted into a customer table, right? Which, no problem. And there are some attribute converted into column, no problem. And this is in the lower part, it says it represents instance, right? And so that leads to a very simple, but also very difficult question, right? Philosophical, actually, a little bit, to talk about what does that mean by entity? What does that mean by instance, right? And in the technical environment, in system, they have a specific role to play. Say for example, if you go to your data table, every row will be a instance of the, say in this case, customer. So one row is one customer, two rows is another customer. So each customer is an instance. But all together in the table is called an entity or table, right? So that's easy to understand technically. But conceptually, because a lot of time we don't really see the data. We see when especially when you are facing a large system, when you're facing a big system like SAP, it's the data is sitting behind it. Nobody give you documentation. So which one is which become a little bit more confusing, because customer can be an entity, can be also be uh, an instance in another class, right? So that concept between instance and entity, and if you are willing to take my other class, MIS 552, we will talk a little bit more about the difference between class and instance. In this case, entity and instance are different. But the point of bringing out this particular slide is to tell you, in computers or in information systems world, notation matter a lot. So all of you have programming experience, and you know that one of the biggest trouble in writing computer program is you're always getting error message. Even writing query, you get error message, right? And in computer programming, the first error message you usually get is syntax error, because you don't understand the grammar, you don't understand the keywords and how to write them. So you get syntax and syntax error need to be removed before you can go into what was the other one? The other logical error, that's secondary. So in here, in database schema, you have to be very careful as well. Pay attention to the detail about how a certain definition are written. Graphically, if you look at the difference between the entity and the instance, you notice that not from the content, but from just the graphic, right? So the top, of course, they have two different colors, but usually in information system documentation, we use only one color, black and white, right? So if this is black and white, and it seems very similar to each other because they are all rectangle, and the one on top has a bar, so is a name represent. But more importantly, what I want to point out is, if you look at the blue or the customer entity, it has a shadow. See that shadow, right? Shadow usually represent what? A thickness. So in this case, the notation is actually use the concept of you stack a bunch of kind of customer record together, become a deck of something to represent the difference between them, right? So that is one. And so when you see the notation, well, of course, this type of notation only used in this textbook. So when you go into a different organization, they will use different way to represent the difference between entity and notation. And if you, actually, to say this, because when I was starting to write C++ program a long time ago, when the C++ was first introduced, I was confused between object class and object instance. Right? So, when I write computer program, it's always because it's totally different from the traditional sequential type of programming logic. But anyway, so it's very important to know which one is an entity, which one is instance, or more importantly, to know the notation, right? And second, notation is important. In ER diagram in particular, they have so many different standards. And later, when we get into Microsoft Visio, you will see all different kind of standard. So in your textbook, use 3 different standards. Unfortunately, that's something I actually emailed the author 10 years ago. Says okay, it's bad, but he wanted to introduce the standard anyway. So the thing on the left is the original ER diagram, and the ER diagram was invented by a professor called Peter Chen. He was a PhD student at MIT, and so when he was a PhD student. He wrote a dissertation, and that become ER diagram. The way it's about the same time, a little bit later than the normalization theory. So normalization theory is, I think, is in the early 70s. This is late 70s, 1978, if I remember correctly. Right. So he starts a new way of building database using entity relationship concept. And but over time, the notation moved from the left to more of the right, right? So nowadays we use just a rectangle to represent a table, and the attribute will be simplify writing within the rectangle instead of using. So the one on the left is very inefficient. It take up too much space. So that is one. We're going to be using the right hand side as a standard. But later that in the textbook, you also see that in the relationship representation, they use this particular diamond to describe the how two things are related to each other. And this is important. The diamond, or yeah, probably best described as a diamond, is because in requirement analysis, because when we build database, when we try to study data, in data we call data requirements. Say you want to build a database, what are the required data you want to store in the database, right? And this requirement is usually based on something what we call business rule. You need to have a rule, a policy organization decided on what you can or cannot do, right? And that business rule, the policy, determine how the database is going to be set up, how the system is going to be set up, right? So one of the biggest problem in using information system, especially commercial off-the-shelf software, is that when you buy a software from the vendor, and they use a different way of treating their customer, or different way of handling relationship. Let me give you one realistic example. Say, for example, if you have a car dealership, right? And imagine yourself, you're going to buy a car from a car dealership. And so they're a salesperson, right? They're a salesperson dealing with you. And we know that the negotiating between salesperson and the customer is important but very troublesome process, right? If you buy a car, you know, I hate to talk to buy a car because the salesperson will just try to sell you everything. They will keep you in the car dealership for a very long time, right? So so when we're dealing with a salesperson and the customer relationship, and those events can be recorded because later you want to serve your after sales service and so on and so on. So let's think about this two entity. One is customer, kind of similar to the one in the lower part. You have a customer, and you have a employee, right? A salesperson, right? So imagine the following situation. You go to a car dealership one day and you talk to a salesperson, right? But after you kind of negotiate and looking at the car, you didn't buy a car. But the customer, the salesperson already know what you want, and you probably already approach the price you can agree upon, right? And the second day you go in, and your salesperson is on vacation, and the car dealership say, "Oh, no problem, we'll send you another salesperson." That's bad, right? Because you need to restart the process again. So in your car dealership, then this has now become a business policy. Will you allow that every customer go into your door facing only one salesperson, or he or she can replace or take the place, become many? So the relationship between customer and salesperson, is that one to many or many to many? Right? That is the question we are asking in this realistic situation. And that one many to many relationship is defined in ER diagram using this relationship, right? The line between two entities. So how you define it become very important, because now if your company say you can have only one to many to serve your customer better, and then you want to make sure in your data model is one to many. Otherwise, that it can be simply assigned to another salesperson and or randomly rotate to another salesperson. That's not good, right? And so this is an example of business rule going to database design. And so well, from a database design perspective, it is very important because what attribute you put into each entity and what kind of relationship you build for each entity or between two entities are exactly what you need to worry about when you run a business, right? So a lot of time and even database or the well, I should say information system worker can inform the business decision maker to see if that's a good or bad policy, right? So that in this case, that the multiple salesperson or single salesperson can be is debatable. So your organization need to decide, and it doesn't say that the single salesperson is always good. If you have a business run, say no negotiation, all the car prices the same. Why you need to have one? You want everybody to sell to help you as quick as you can. So that multiple salesperson may be good for your organization, but it depends on your organization strategy and policy. So that policy will directly influence the relationship. So let's go into the some of you have learned ER diagram before, because in university usually will give you a case. We already specify the business rule. So when you build ER diagram, there is a correct answer about the relationship between two entity, right? And so if you draw the relationship incorrectly, your professor will mark incorrectly. But in here, I want to kind of ask you to relearn that. There is no fixed relationship between any two entities. It all depends on how your organization want to set up the rule. So that business rule determine the correct answer for your relationship. Right? Even with the correct business rule, during the implementation, there's still room for you to change the relationship or cardinality. Okay, I'm using the term cardinality to describe the one-to-many, many-to-many mapping between two entities. Right. So that's an important lesson I think I want to mention before we start. So this is a standard that using a diamond shape, but the standard we're going to be using is not that standard. So it's that we already seen two. One is the oval shape representing attribute. The second one is we use a diamond shape to represent the relationship. And what we are going to be using is the one look like this. All right, so the one on the top and the one at the bottom, these two are the same model. They describe the relationship between department and employee, right? But they represent in notation differently. On the top, we have this diamond shape we see earlier. And so the cardinality is represented by the diamond and these are strange notation. One is an O, the other is a bar, right? 1 and 0 or option and 1. It depends on how you describe it. So this is it's called the ER model version, and this is one of the versions. I think it's called the IED 01 model, right? So that is a standard. But more and more that after we modify and universities start teaching ER diagram, the model morph into the one that you see in the bottom. It's called the Crowdfoot version. Right? The Crowdfoot version will be the one we use as a standard in our class and assignment. So in your assignment number 7, you need to use the Crowdfoot version. Right? So in here, I want to ask you, when you compare the one on top and the one at the bottom, right? Other than the color difference and notation differences, well, just in terms, in particular in notation, do you see anything that you feel like the B has what? B has minimum and maximum, and the A actually A has maximum is in the middle. So that's the minimum from the side and maximum in the middle. So yeah, so this is 0 and 1. This is 1 and many. So that's how you read it. So this is 1 and many, 0 and 1. All right. So that was good. It's different. Notation different. Any other? The other important difference is, if you look at B, why they use the dashed line, right? So, it actually, in this particular case, it really doesn't matter. Dashed line or solid line, they are all line. They all represent relationship. But don't you feel like a solid line look better, right? But why are they using a dashed line, right? If they use a dashed line, there must be a purpose of why they want to use a dashed line, right? You gotta have idea why they're using a dashed line. Conditional relationship, good guess, very good guess. Yes, there are certain conditions that to determine whether the line should be solid or dashed, right? So we will hold that idea for a while and move on forward, and I'll explain in very quickly. But anyway, what we are going to be learning here is the crow's foot notation. Right? Crow's foot is the trident that we are drawing here. And so in crow's foot, we have something called a minimal and maximum cardinality. Basically, we specify a range. Now, in modern day, a lot of computer science programmer in particular, they don't use the crowd foot anymore. They will use a UML standard. And UML standard, instead of using the notation or the simple one and many or zero and many, they will use number. So they will use 0 to 10, 0 to 1, be more precise in specify the range of how many entity or how many instance you can have on the other side. Say, for example, in the classroom we have here, we have professor and student. I can specify as one professor, 25 students, no more than 25. Right? So I can specify a number. So in modern programming language or model, we use UML that we can specify a number. But in data model, usually we are still very, well, you can say abstract, more abstract. So this is a more abstraction model. So instead of specify a number, we just simply say one many, right? Give you an idea of what the relationship should look like. So so the concept of minimal and the maximum cardinality, it's actually, if you think about it, it's very easy to understand. But as a professor, I have to have the job to help you to make it more clear, right? So this is how you should be doing. Now, in object-oriented programming, there is a skill, right? Every information system person, including you, yes. That's what I'm going to be talking about. Okay, so so the question is, what does that minimum and maximum representing, right? So we're going to be looking at that. So in a computer programming world, there is a I was trying to say some example. I forgot which one. but anyway, okay, let's go in here. Oh yeah, I remember now. So one important skill and remember in the beginning of the semester, I tell you that whenever you are facing a computer system, you want to make sure that you are you know what you're dealing with, what system, what platform, what user account you use. Because in the same system, you may log in with a different user, right? Say, for example, you're helping your friend working on his or her assignment. So you go in there and finish up their work. And later on, you want to work for your own assignment, but you forgot to log out. You do the same thing, and later on you shut down the computer, you go back home, you log in, you cannot find your work. Why? Because your your work is left on your friend's account. Right? So that is just a kind of an example here. It's very important to know what you're dealing with, right? So it's also that especially when we are dealing with programming environment or the database environment, and especially when you do not have a physical thing to look at, you just look at the code, computer code, right? So one of the important exercise, actually, when I was a student, I would do this. It's called a CRC method. CRC method is a method called the role play. So instead of using your brain to think about all these interaction between computer code, you try to imagine yourself if you are the computer. When you talk to another computer, what you need to do, right? So when you imagine yourself as a computer, now you know how to program the computer. So that's the basic idea. So same thing here. So when you're looking at the data table and how they relate to each other, you have to pretend yourself as one of the table and look at the other table, right? So in this example, we have a relationship between a department, look like an organization, a department, and department has many employees, right? So conceptually, we know that department will have many employees, right? So the business rules is how your organization set up in department, right? So this looks simple model, but can talk about the modern day management organization structure. Traditionally, of course, we have something called the organization chart. It's a tree structure, right? On the top, you have CEO, COO, CFO. Under COO, you have different department. Different department, the employee or supervisor. That tree structure. But in a real world situation, it's not that simple anymore, right? Say, for example, if you are say in UIS, does every professor belong to one department? We could work for multiple departments, right? So your membership in department become not as simple as one to many. So that representation, in this case, the model now will have to kind of go back and force you to think about how they relate to each other, right? So let me go back to this example. So the way that we role play and look at the relationship is that every time you try to figure out so-called the minimum and maximum cardinality, right? You pretend yourself is the department, right? Not the department head or department chair, but you are the department. Well, I'm a department. So if I'm a department, virtually like a robot, now under my record, I have employee, right? So what are the minimal required employee for me to become a department, right? So if you think about this, if your department has 0 employee, why you need a department? It's empty, right? Will that be a situation that you create a department, there's no department, nobody is in the department, but you still have a department? Right, think about that situation. Right, if you run a company, you say, I'm gonna create a sales department, but we don't have anybody assigned to sales yet. If you're running the company already. But if you're starting a new company, you don't have a company yet, you are just starting a new company, you have nobody. Then you want to build a database, and then in that case, you might have 0 employee, right? So it's possible. But again, you require to have one or not, it's up to you. But basically, this is the relationship we're looking at here is, in order to create a department table, I want to make sure that I have at least 1 employee under my list. If there's no employee, I'll delete my department. All right, so that's what this particular document. So that minimal cardinality is from department, I look at how many employee I have. Minimally, I need to have 1. And the maximum means that, okay, minimum 1, how many more employee I can have. In this case, you can have many, right? 1 many. So how many? It doesn't say in this particular model, right? As I mentioned earlier, that if we are using UML model, this will become 2 number, will be 1 and maybe 30, right? So 30 is a reasonable number because it's one of the number that our human brain can handle. So I don't know how many. I'll leave. If you take my 552, I'll tell you about human memory and how that related to information system. But for now, so this is how we look. So reversely, you look at employee. I'm an employee. I work for the company. I belong to a department. Right. So the question is, how many departments should I belong to? Right. So in this example, I'm saying in my company, you can hire into our employee, but if at the beginning you don't assign to any, maybe you're just a trainee, right? Or some sort of intern. So you don't belong to any department. You're just a generic general employee. But at most, eventually you'll be assigned to 1 department. If your job change, I'll move you to another department, but I can only belong to 1 department at a certain point in time. You can change, but you can belong to 1 at a time. So that's what this model said. Reasonable or not, that's for your business rule to discuss. Your organization, your company to decide, right? But that is how you look at minimum and maximum cardinality, right? So, but it's really when we draw the model, especially when you are new learning the model, a lot of times you will reverse the notation, right? But the best way to make sure you have the direction correctly is to role play. You pretend yourself in one side and see the other minimum maximum. That's how you see the correct cardinality, right? So this is called cardinality, and in some places it will be called multiplicity, meaning that the multiple mapping between one entity to another, right? So that's another important idea that we need to grasp before we start moving, right? All right. So let's go to the why the line is solid or dashed, right? So this leads to some of the concept in database that is a little bit kind of confusing, right? And but the example here is not very good in the textbook. But basically, I like to use another example further down in the slide, but I want to avoid spend too much time in searching for slides. So I'll just use that example for you. Further down the slide, you will see one example. They use the concept of if you have if you're a rental company, housing rental company, all of you probably are renting a house or something, right? So in housing rental company, they have a lot of property. So you have a building has an address, and within the building you have an apartment number, right? Apartment 1, 2, 3, 4, right? Apartment number. So if you want to record the concept of apartment, each apartment, then if you look at the apartment, can I say just simply say apartment 1, and you can identify you know what apartment 1 is? The answer is no, because apartment is part of the building. So the concept of the building is say building 100, apartment 1. If you have 100 and apartment building 100 apartment 1, it's more specific. You can identify apartment. But if you only say apartment 1, it's kind of hard to understand or know exactly which apartment it is. So this relationship between building and apartment is more like a parent and child, right? So you need to have building before you can have apartment. You don't have building, you don't call this apartment. You call this a building, right? So the relationship between apartment building is a parent-child relationship, and the child depends on the building, and that child is called a weak entity, right? A weak, and the parents is a strong. So it can stand there. The building has an address. It can exist on a data book by itself, but the apartment cannot exist on the data book by itself. Have to depends on the building, right? So that is the relationship between them. So this leads to in other situation. Oh, so this is a building and apartment. Other situations, such as the situation we have here. Right, employee and skill, right? In this case, they use a dash line, right? Well, let's forget about dash line for a while. Let's think about employee. So if we create a table of employee, and this employee has a lot of information, name, ID, phone number, email, that sort of thing, right? So the question is, does the employee need to depend on another record or another parent? No, you just create a table just with all the things. Good. What about skill? Say you have a skill of database management, you have a skill of security, you have a skill of network administration, right? All kind of skill. And the skill is generic. It's not it's so can so well let's put it this way. Its skill record can exist independently of person. Really? If let's put it this way, let's just say, well, we are discussing your future career, right? Future career. Let's sit down and open up Excel spreadsheet. Let's talk about what kind of skill is employable. So you can say, okay, this is security skill. Can I create this table without the name attached to that table? Okay, so this is why I want you to unlearn your ER diagram model, right? So the skill itself is an independent concept. You can create a database without, say who owns the skill. But if you have somebody own the skill, that makes it more useful because now you know who to hire and that sort of thing, right? So this is also independent. So both of them are independent. When you have an independent table that can be created and record without losing any information, we call them strong entity, right? So both of them are strong. So when strong entity relate to each other, their relationship are dashed because they don't need to attach with each other. But when you have a relationship which is a parent-child, the child have to attach to the parent. So the solid line represents a strong linkage between a weak and a strong entity, right? So that is what the dashed line means. Dashed line means that these two entities are independent of each other, but they have relationship, right? So this question is now that if you have a husband and wife, should that be solid line or dash? In modern day, it's dash, but in probably ancient time will be more like a solid line, right? So, but again, it's just telling you that the business rule, this is business rule, can change, right? And the one of this more strange thing in information system is because information systems are artificial, because human define what it should be doing. So as a programmer, you can pretty much do anything you like in the system, right? But the usually a good advice is that what you model or what you build should reflect more the reality, the better, but not necessarily true, right? A lot of time, reality is also bad. So you don't want to mirror exactly the reality. So the virtual world has that flexibility of changing the reality relationship. But this is something that when we get into the concept of design, and in the context of organization database, a lot of time we discover some of the problem that you cannot use the existing system to run your business. You need to go in and change how they relate to each other, right? So that's the actually what chapter 6 is trying to tell you. But of course, with the short time we have, we don't have enough time to find that example says, okay, you go in there, modify their relationship and change it. But actually, chapter 6 go through an entire process of showing you how to do that. Right, so the specific name for a weak entity is called ID dependent. And I introduced this word because we're going to be using that in Microsoft Visio. So now you go to Visio, you understand what Visio notation means when you are using that software. All right, so that's good enough for now. And if you go further down in the textbook, they will introduce all different kind of examples, including this exclusive, inclusive relationship, parent and child relationship, arch relationship, and so on and so forth. I want to introduce you to two particular relationships, right? And that is useful in our assignment number 7. One is this one. It's called a ternary relationship. A ternary relationship usually represent the one of the most complicated business operation we have. In this case, project management. So if you want to manage a project, project management, by the way, is probably the most complicated software that, especially when we enter into the age called the gig economy, right? So gig economy is what, everybody is a temporary employee. So you assemble together for a particular project. Say we want to build this. I forgot the name of the rocket, but anyway, so we're going to build a rocket, right? And together, but the rocket project 3 years. What happened after 3 years? Everybody go back to their own home and find another project, right? Or if you are more lower level, you are a person laying bricks. You know how to lay bricks, and so you build this house for 1 month, 2 months. You go to another house, and your coworker keep changing, and the building you build keep changing. The skill required might be different, slightly different as well. So you keep rotating. So in managing this kind of project, you need to manage many things, including time. A person has a certain amount of time. You are tied to this project. You cannot work on the other project. Your physical location, right? So you work on in Springfield. You may be able to work in Chicago, but probably more difficult in New York, right? So even though you are available, you cannot go to New York, right? So you have to manage the location of that person. You have to manage the resource, that money you have, what kind of material you can buy at certain location, vendor associated with and you need to have a designer, in this case, architect project, right? And how many times they can meet together, and what kind of job you meet every time. So all these things together, including scheduling, resource, human, money, all together become a very complicated project. Right? So writing a software to track all these projects become difficult, right? So this is why that we have uh, this online software called Doodle. Doodle. Does everybody know what Doodle is? Doodle is, say, for example, if you want to, next week you're taking an exam, right? So you talk to your newly acquainted classmate. Say, can we find a time together? We will take the exam together. Which is allowed. I didn't forbid you to do that. And so it's a fair game. But as I mentioned, that I randomized the question so that even you work together, you need to, and you have limited time. So, but it's a good, I find, especially you can work on the short answer, right? So that's good. So and you need to find a time stop together, right? The primitive way is why you email each other, say, I do have time and so Monday, Tuesday, Wednesday, what time? And then you're going back and forth and find the right time, right? Or you can use Doodle. So Doodle, Doodle. Right? There are many software similar to that. There's another one called Monday.com. Right? So you can go in there, they give you free service. So you say, okay, we're going to be scheduling a time, 1 hour between Monday and Wednesday, right? So the Doodle will give you this, and it will send email to everybody. Everybody select their own free time, right? And then you can, so if you never used that before, it's kind of fun thing to use, right? So why, and you will start imagine why my Microsoft Outlook does not have that feature. Outlook is a scheduling, emailing software. It's supposed to have handled this feature already. So why we're still going to Doodle doing that? The reason being this type of software is very difficult to write it well, right? So if Outlook or Microsoft Exchange server put this feature in there, it might make user confusing, very, very confusing, right? So, or have security issue going on because there are a lot of sharing time and the calendar. And so every software company try to attack this problem and give the user the best way to schedule their own time. So that story just tell you that this is a difficult software design problem, right? To start with, but what good about this particular model is, and this model we call, and actually your textbook use the term as well, we call them a pattern. Because what is the best way of design? Copy and paste, right? So in school, we think that copy and paste is a bad thing, but it is actually a good thing because in software, we have a very important concept called reusability. Everything you write, you don't want to reinvent the wheel. So that's why you have a lot of library you can copy from and doing all the things. So copy and paste is good. So whenever you face a business problem, you want to build a database or examine to see if the database is good. Look at a good practice. What is the good out there? how other good database are designed. So this is one of those. If you are handling a project, you know that every project has a lot of this says assignment, but it's actually job. Within a project, you have a lot of job, right? So if you imagine that many of you will be taking project management class, the first thing you will learn is using what? A Gantt chart or Gantt chart. You have to list all the tasks you have to and put them onto a timetable, right? So that job is one of the requirements that you need to handle. So job is in the middle, assignment is in the middle. And every job involves the negotiation between client, architect, in this case, architect. It could be a engineer or employee, vendor or something. Everybody go into this job and complete the job together, right? So this makes sense, right? So this is more like a pattern. Pattern can be modified, but it gives you the basic thing. Okay, at least I know that people involved and the job, task, and overall structure that have that relationship, right? So that in this example, it's called a ternary relationship, but it's actually multiple binary, right? So the relationship here is one to many, one to many, one to many. There are three binary relationships define a ternary relationship. If you expand this a little bit, you can put another one here. Say in this case, I need the architect and client and maybe a salesperson because somebody have to decide on the price. Then put a salesperson here, become even more dimensional than the three dimension we see here, right? So that is one. The other one, we unfortunately do not have too much opportunity to practice, but it's probably the most important pattern, right? Is this one. This one represents a concept in many database practitioner database book. You will see this over and over again. They will use this term called line item, right? So some book will call this a line item pattern, right? And that will simply call this a transaction pattern. So basically this model or this particular arrangement of data table is the foundation for almost 90% of the database we have today, right? So regardless of what you look at, the university registration system, and or in this case, this example is a sales. You go to Walmart, you buy something, right? You buy something that need to be recorded, and what need to be recorded? Who is the customer? Who is doing the sales, and what item has been sold. Very simple. So if you look at your receipt, the receipt has all the thing you buy, and that everything, every line of the thing you buy is called line item, right? So that line item, and you go into accounting class, they will also use this line item as a foundation for doing all these calculations summary, right? So this particular structure is the basic for almost all the, if you replace, and the one in the middle, called the sales order, is the transaction happening, right? So if you have replaced the sales order with other transaction, for example, if you say at the beginning of the semester, student need to register to a class. If you imagine that your registration is very similar to sales. You sign up for a class, you have to pay the tuition, and a professor will be assigned to you that for that class, and so on and so forth. Right? So if you imagine, this is imagination, sales order replaced by registration, which is the concept of transaction. You will have student on the left, and registration, you have course on the right. Which course? No, I'm sorry. You have who is doing the registration for you, and you will have course will be equivalent to item. How many courses you're gonna have? So in your registration, you have multiple course. So this is item become course, sales order become registration, customer become student, right? Maybe you don't need a salesperson because that's automatic system you're doing registration, right? But the basic structure is there. You take out this become registration transaction, right? That's how that's the powerful of this particular thing is, right? So you replace this with anything else. Let me do one more exercise here before we move into the VCO environment. Say one of the things that in the United States we do is we like to watch sports, right? So in recently that in our region, the most important thing, I don't know for you, but for me is to watch a nearby baseball team in St. Louis called Cardinals. St. Louis Cardinal is doing very well. They are the leader in the Central Division, and most importantly, we have a baseball star called Albert Pujols. He's in his last season, he's making the milestone. He's number 4 now in all-time home run list. So it's the most home run person, close to 700 home run in his career. So we're tracking his game. So if you put game in here in the middle, right? So you will have probably team on the left, maybe a team or the host. I mean, one is the host team, the other is the away team, right? So two different team concept going to the, so for each game. Each game will have a lot of this record, including how many hits you have and how many home run you have. So the item will be the hits and home run and score, that sort of thing that you can record. Yes. It could happen. You could do that. That's true. Depends on what you want to record. So what I was describing is describing the game in general, but you can put player in there. You can put the say, well, more specifically, pitchers and other player, and it can create another design as well. But this is a pattern. It gives you a structure, and now you modify the pattern to become your design. So copy and paste is not only just copy and paste. You copy, modify, and paste. Right. So that's good practice. Right. So even though that we have a very strict called a plagiarism policy on campus, but learning is always best by look at what other people has done and you improve. Right. Improve. So this is what we're going to be doing in our exercise. So with those two patterns, ternary relationship and line item, that we can start working on our assignment, right? On our assignment. So what I will do is I will open up Citrix. Right. Okay. Okay. So we're going to our system. I'll use a full screen or entire desktop when it's ready. Okay. You consider my name as a privacy concern because we are recording this using Zoom. If you are in a Zoom meeting, that your name and my name will all be in there. There might be a little bit of privacy concern there, right? Because maybe you don't want people to know you're studying at UIS. You want to be under the radar. And once you get a degree, you go, oh, I got a degree, and you don't want your coworker to know. But there's some concern there. But I don't teach security, but security, just like anything else, is it's a trade-off between security and efficiency. And the more secure is less efficient, but less secure, more efficient in terms of system. Okay, so the software we're going to be using is Microsoft VCO. And it is not the best software to do ER modeling, right? In Google environment, in a few years in our campus, I use another software called Lucy Chart, just like the electric car Lucy Chart, which is pretty good. But we rather use something that we can control internally, right? So that's unfortunately the Google account that we have on campus cannot use Lucy Chart because, by the way, if you have UIS net ID, your net ID give you access to a new Google account, right? Which is controlled by the university because you can use some of the so you have additional Google Drive that you can use. But once you cease to become a student, then that space will be taken away. So using your UIS account is a Google account. We're going to be using VCO to start VCO. Simply just by searching VCO and start VCO. And when you start VCO, and if you are in a classroom, I will recommend you do that now. Okay. It is very important to start a VCO correctly, right? VCO is a generic diagramming tool, right? So we don't call that, it's different from Photoshop, because Photoshop is more like artistic drawing photo modification tool. And diagramming tool are used more precisely in areas such as engineering. In this case, we are doing software engineering, right? So it is important to follow the standard of every engineering discipline. And in VCO, it is organized by the concept of template, and templates are grouped by discipline. So what I did is I click on more template. So it will come give me some categories, and the version we are using, I think, is 2019 professional edition. And you see that the category will have network, flowchart, software, education, business, database, and floor plan. Right. So you know that next time you want to buy a house, you might or do some interior design, floor plan, maybe the one that you want to. And you want to go another classes, drawing flowchart. You can go use a flowchart template. Right. It is important to select the right template because every template has their own rule in terms of how and why and what you can do. And in the earlier version of the VCO, they can even do reverse engineering in some situation. But Microsoft, after they test experiment with that for a few while, decided not to because it was a disaster of reverse engineer a lot of computer program code, that sort of thing. So we're going to be using database template, no surprise. Let's go to database category. Under database category, you will see so many different selections. Right? Some of them are more familiar to you, and some of them are not. Say, for example, you have this IDEF1X database notation that is used a lot by a company like Microsoft, right? And you have this actually in Microsoft Access and SQL Server, they use this one in the second row, the first one called the database model diagram. So if you use Microsoft Access or SQL Server, they can visualize your table relationship using the one here. And we are going to be using, guess what? Crow's foot notation, right? So this will be the second one. There are some other things that we're going to be seeing in another class for VCO's concern. So we're going to be using Crow's foot notation and select a blank document, right? And usually I'll recommend the first thing you do is going to design and change the orientation to horizontal, because in your assignment, you're going to be submitting your assignment to me in VCO file, and I'm grading your assignment on computer. So if you use a vertical orientation, it's more difficult for me because I have to flip my monitor to read it better, right? So horizontal or landscape orientation is better for me. And so we will use that, right? Second thing, before you even start drawing the diagram, is going to this menu category called View. Going to View, it's very important because without changing this property, it's very difficult for you to edit the diagram or modify the diagram. Now, what do I want you to do is, if you see that View, under View, there is a middle category called Visual Aids. Right? And there's a little expansion, sort of like a icon here. Click on that expansion. So Visual Aid will open up this options. says, okay, currently active snap and glue, right? Snap means that when we are drawing the diagram, it will snap to a grid line, for example, or snap to a, so it's easier for you to attach line. So you don't need to kind of like in Photoshop, a lot of time you have to kind of go very close and zoom in and connect line together. In here, it has automatic snapping feature. The other one is glue feature, and you will glue to certain shape. So it will move together with a shape object. So when you rearrange the object in the diagram, it's easier. What I want you to do is on the glue to, on the right-hand side, glue to there, click on the very top, says glue to shape geometry, right? That will help you solve a lot of editing or cosmetic problem when you are drawing diagram, right? So that's a preparation. So the other thing we're going to be doing is that we're going to be open up a second page. You see the lower part of the VCO screen, it has page one, just like Excel and other software, you can create multiple page. So a model, one file can have multiple diagram, right? So in that case, if you are exchanging file, you don't need to set multiple files there. Let me create a new page. That's called this. You can change the name as well. That's called this project. That's called this vendor. Okay. So project is because we mentioned copy and paste already. And I mentioned that our assignment is a project management project.inc. So we're going to be copying the project ternary relationship in here, right? So what we're going to be doing is the ternary relationship has 4 entities. So we just draw 1, 2, 3. Not exactly copy from text to here, but we are kind of copying manually. All right, so 1, 2, 3, 4. So that's the structure. And in the middle, I'll call the middle one name of the object as task, right? And the lower one we call this project. And remember that on the top we have customer client, right? So that's just called customer. That makes sense? Project, task, customer, employee, right? And the original model was what? Original model was project, assignment, client, architect, right? So I replace architect with employee. So you can imagine that project has many tasks. Every project this is the engineering project, they'll do a lot of things, right? Every thing they do is a task. And every task needs to be complete by an employee, probably with the opinion provided by customer input or customer signature. So when you complete something, the customer say, okay, yeah, this is done. This door is good. They sign off, right? So you have a customer sign off a particular test. An employee work on the test, and every project has a lot of tasks, right? Right. So now figure out well. So once we have the entity, the next thing to do is identify the primary key for each one of the entity, right? And we talked about primary key last week very quickly through normalization, but basically we want to select a something used to identify that particular record. Let's say, for example, in this one we can use all surrogate key, and also use a term that we use in normalization. Surrogate key it's just like student ID, the artificially created number you can use to identify. We can call this so it's easy to just call this customer ID, right? That's easy, right? Don't enter any attribute yet, right? So just enter the primary key. So the task will be, I don't know, task ID or task name, either way. It could be a surrogate key. Let's just put task ID to simplify the thing, right? So you can do this is anything. Employee ID, project number. How's that? So each one of them has a primary key already. Good. So the entity seems to be are very good. You know, for entity quickly model the project management situation very well. Right. So now we start thinking about their relationship. The relationship, the first thing we do is to create a copy and paste template, right? In Visio, there are a couple of ways to do that, but basically, Visio is not doing very well in terms of providing the best notation for us to use in terms of the visibility, in terms of the size. For example, one of the things maybe we can change to make this particular model better is change that to black and white. Right, so change it to black and white. And now this is actually much easier to read than that blue color thing, right? So you know, very clear black and white thing. It's actually print out better in the black and white printer. So you know, let's use black and white. And second, we're gonna be building relationship. The relationship, I drag and drop one from the left stencil to the right, and as you can probably see that it's a crowfoot notation, but it's very small. It's not doesn't read very well, right? So to change how it looks, it's just like many other. This is standard in Visio. You want to change the shape, the property, color, size, and thing. You right click. You right click on this particular thing, and you go into property, format shape. Format shape will open up a property panel. You go into this line, and they will give you this on the right hand side says beginning arrow size, ending arrow size, because this is a arrow line. So the default is medium. That changes to extra large. Right? Extra large reads very well on the computer screen. To me, at least, that's changed that to extra large. So this become a so now you can copy and paste. You don't need to kind of drag and every time you copy and paste. Now in Visio, there is a features that you can create your own template or stencil, right? And to do that, you can, this is actually not what you need to do now, because in our virtual desktop, you do this time, next time it will be gone. So, but you can actually do that by, you see, that if you click on that, more shapes, there is on top, there is something called my shape, right? That's called as going to the favorite shape. So what you have done now, if you open up my shape, my favorite shape is on the left hand side, the stencil, the shape has a new category, and a new category is your favorite shape, right? And if you create something new in your diagram you want to reuse, you can always drag and put them back in here and say yes. Let's say a large relationship. So that way we have something that we can drag and drop and without modify it every time, right? So this is customized. And a lot of times when we have a shape we don't like it, we can always create a new one by simply modifying or regroup them together. So that one we can now use. So now we're going to be doing this relationship between project and task, right? So what is the relationship between project and task? Every project has many tasks. That makes sense? And every task belongs to one project, right? So that statement is a little bit ambiguous because, you know, you will say, okay, the task, let's say, for example, the task of putting on the floor, putting on floor. It's a task can be belong to many projects. What do you mean one project? But that particular floor is only one project. Right? But again, this will get into a more debate things. Some of the job can be is common. Some of the job is not common. But in this case, to save time, I'll just say, okay, one project has many tasks, but every task belongs to only one project. Every time you arrange, have somebody do a flooring, this flooring is only for this building, this house, this project. So one project, right? So one many relationship, one many, not many relationship, right? And when you are drawing the diagram, and this is where I want to show a little bit visual capability. So when you move the one side, one end of the line, say in this case, many end, many will go to the task. But when you move the line, you see when I move the line, the highlight, the green highlight change from one place to another. It's basically telling you which block of the shape you want to connect to. If I don't, if I go let the entire shape specify, it go all around the rectangle. But if I go to a specific attribute, you only go to that attribute, right? So let me just try to drop to the entire shape. Entire shape, you automatically snap to the one of the snapping point. In this case, in the middle of the shape. So that's many side. And if you do that in the beginning side, which we want to drag to the project, you also show multiple connection point, right? Let's just try to move to the entire, right? Connecting to different place has different meaning actually. But in the ER diagram, we do not want to be too specific. When you go into the database design, have to be very specific. Sometimes the key have to connect to another key. But in this case, we are talking about relationship between two entity. So this is good. And that little green dot means that it's already connected. So once two shapes are connected, you can move the shape and align. The one on top is not connected very well. Right. It will, when you move when they are connected, when you move the shape, the line will go with the shape, right? So that's how I think. And the glue to geometry allow you to move the line along the geometry, right? That allow you to customize and make it prettier. But this is good so far. And finally, looking at this one-many relationship, we need to look at two other things we just discussed earlier in the class. One is, do I need to use a dashed line or solid line? The second is minimal and maximum cardinality. So we look at the project. Do we need to have at least one task to be called project? Or no line can be a broad project. You can go either way, just like what we talked about earlier. Let's just leave it alone that way. Says, okay, you can create a project. We don't know what job need to be done in the project yet. And maximum many tasks, that's okay. Every task is belong to one project and one project only. That is good, right? So that cardinality seems to be okay. But now let's look at the relationship between task and project. It seems like the task is attached to a project because that particular task, if you do not define it, if you don't have a project, you don't have the job. So the solid line is good because the task is a weak entity in this case, right? But if you want to just assuming this is the modification or editing thing, if you want to change the line from solid line to dashed line, this is where what I did is I right click on the line and show up the formatting menu. And on the top, you see the top portion, there is options that set identifying, right? So if you recall, we have ID identifying relationship. Identifying means that the task need to be identified by the project. Task is weak, right? So it's checked. If you uncheck that set identifying, uncheck that box, this will become a dashed line. This will become a dashed line, right? So that's how it, but in this case, I want to change that back to set identifying. And the other thing is, if you want to change this, say, for example, every project need to have at least one task. And then the way to change it is to change the beginning and end cardinality or symbol. So if you move to the beginning symbol, it says 0 or more. If you change that to 1 or more, and it becomes a line and the crowd foot. Right? But in this case, I want to keep it actually 0 or more. Zero more. Right? So I can create an empty project without specifying test, and later I can define the test and identify employee. Right? So now you know that between employee and test should be dashed line, because test and employee can separate, exist by themselves. Because employee doesn't need to exist, and test doesn't need to exist because of employee. Test need to exist because of the project. So project is a parent, test is a child, but employee is not a parent, test is not a parent to each other, right? So this is a dashed line. So every employee can work on many tasks. Every task can be done by many employees, right? So that will be many to many. So we can still use this one, drag and drop, connect them on the line. If you have this weird relationship, you can always add it. So this is many to many, so we can change that to, first of all, non-identifying. Second, change to every employee need to work on 0 or more task. Every task can be done by 1 or more. Oh, the other way around. 1 or more, 0 or more. The orange line? I don't know. I should not have that, but for some reason I click on something that show up. But anyway, I would try to delete that line. Oh, delete the whole thing. Undo this. Okay. Yeah, undo is probably better. That doesn't go away. So okay, anyway, forget about that line for now. Let's just do the thing we need to do. Oh, that now it's out. So it's probably a mark line for some reason. Okay. So I'm not gonna be worrying about too much on the cosmetic of when you are working on this, you worry more about the cosmetic. One more. I just do this. I just do something real quick, and this is probably one many. Okay, that's good. One customer is involved in many tasks, but every task is kind of you have one customer sign. That's how. So this will give you a basic structure of it, right? Of the thing. And of course, when we build ER diagram, you can put all the concept in one diagram, which will make the diagram very big, and a lot of things are crossing around. Or you can cut them a portion at a time. This is what I recommended in this example. Different concept, different transaction, and I'll handle the vendor in the next diagram. Right. Before we move away from this particular diagram, one more thing. And there is a concept called, we want to keep track of the marriage of employee if they are if both of the couple are working in the same company. So employee can marry to another employee. Right? So, and that relationship is called a unary relationship, right? One after another. And unary relationship is a beautiful relationship, right? Because if you go back to the textbook, and without going to the slide, I'll tell you that organization chart. If you think about organization chart, every position in organization chart are employee, right? So the relationship between like CEO and COO is a relationship between employee and employee. One person supervises another, right? So in this case, employee married to another employee, it's also a relationship between employee and another employee. So this unit relationship can actually be used to represent a organization chart, right? If you define correctly. And that example in the textbook, I would recommend you to read it. They use a box car, train. How do you define a train as an example? You can take a look. But in here, I'll do the relationship very quickly. So the idea is that one employee married to another employee. But in this case, we want to describe the idea of marriage, because now how employee relate to each other can be a boss and a subordinator, and or couple. Yeah, we haven't changed that yet. We're going to be doing that now. So one employee married to minimum one, minimum zero, because you can be not married, but maximum one under current law. Is there a different law in different country of in any one of you? So in your country, you can marry to more than one? Four. Oh, nice. But I don't only have four wives myself. It's just one is more than I only have four mistresses, not four wives. Mistress means that you don't have too much responsibility. But when you get married as a wife, you got to pay for it. But just something that joke. Oh, that's good. Nigeria, Gambia. Okay, I remember. Gambia can have four wives. How nice. Not bad, but if you have money, that's nice. But if you don't have money, that's bad, right? All right. So one of the things we can change cardinality. We want both sides to be 0 and 1, 0 and 1, right? 0 and 1, 0 and 1. So set 0 and 1, 0 and 1. And the other thing we can do is sometimes we have more than one relationship among entity. You can define, and this we can say use a note, right? Double click on the line, you can say married to. And two employee, they are independent of each other, So conceptually, probably a dash line, right? Dash line. You don't need to identify your wife with your own name, but in some country maybe, but in this case, that would be good. Just try to make things a little bit more complicated and explainable. Employee to employee may be supervisor supervising in relationship. So another unary relationship may be so the one on the lower part is marriage relationship. The one on the top is management relationship. So you have one employee manage many other employees, and every employee can be managed by only one employee, right? So yeah, so that's. But this will lead to what about CEO? CEO will not be managed by anybody. He's a boss. Then you probably want to change that to 101 here. But to simplify my job here, I'll just leave it that way. Okay, so Let me try to make one more extension of the now this one. I'll open up the CrowdFood and put another entity here. Material. Okay, I've created another entity called material because every job you do, there are a bunch of material you need to prepare before you can build a house. The carpet, the glue, the paint, put together material. So every job might have multiple, or in this case, material is related to task. It's also related to project, but it's better to attach to task because every little project within a project use a certain set of material, which is different from the entire project. If you manage all the material used for every task, you will have the entire material for the project. So even though material is related to these two, we attach to the task, right? So every task is using okay, I'm simplifying the process a little bit. I just use one to many. And again, one to many or many to many is debatable. Right? So we have this. And materials coming from vendor. So you have to buy from the vendor, purchase vendor, right? So let's keep that in mind here. So what I want to do now is to handle the concept of vendor, employee, material relationship, right? So now let me copy this. So we know that this job, it need to be handled by employee. Employee need to buy material from vendor. So employee, vendor, material, right? So what I would do is I put material here. See that? Oh, undo. I'll copy employee. And I'll use, black and white color. Purchase. So we're gonna buy material, right? So purchase, I will be more specific. Let's say purchase order number, date, and time of the order, right? And we will have, oh, sorry. Okay. So what I did really quick, I think it's really quick, but on the recording, it might feel like it's very long, uh, is that I quickly create a pattern. And if you remember that we have sales in the middle for the pattern I mentioned, line item, salesperson, and customer. So in this case, it's not sales, it's the reverse of sales. Purchase with vendor, employee, line item, and material. Okay. So that's the basic structure. So we will have very quickly, and I know this already. So it's one many. And these are all identifying. So the line item is a weak entity for both from both material and the purchase. And every purchase coming from one or more vendor, depends on how you define it, right? But again, I will simplify by saying, okay, and there will be one employee to press the order for a particular project. In this case, you see that it will be easier if you can move the shape, move the line along the shape. So this part is the reason why I asked you to click on that glue to geometry. Now you have one many, and these two should be dashed line. All right, so now without explaining why it's dashed, I'll just simply change that. So now we have two models. They are the same model because they have commonality. They have employee materials on the other side. So if you move this to the other page, they merge together. But in this case, it's good as long as you keep the definition of employee material consistent from one diagram to the other, right? Let me emphasize one more time. These two diagrams can be merged together or separate. And for the sake of easy to read in our class and to explain the concept using pattern to build a model. So we take that case and use two pattern. One is ternary relationship pattern. The other is a transaction pattern, and build a pretty good model. Pretty good model. Copy these two patterns and build a pretty good model. And that will be your foundation to assignment 7. If you copy exactly, you get at least 80% of the score. Right. What I want you to do is read the case a little more to see if anything that is not captured or anything that is changed, strange. Say, for example, one of the things you might consider is how do we consider the idea of vendor and the material? Because each vendor has their own material. So there must be a relationship between vendor and material. Some vendor offer this material, some vendor offer the other material, and they have inventory problem. So that's something for you to use your brain to how do you attach or create a line, say, between the vendor and material, or add another entity to document some other concept we didn't describe in here. Right. So the assignment 7 does not need to be complete, but you need to follow what we are doing here. At least copy the current 2 diagram format and extend that a little bit. And when you extend, I'll check the part that you extend to see if you extend well or not, to determine you get 100% or 90% or 80%. Right, that's the thing. So that's all I want to do in today's class, actually. I'll use them almost all the time already anyway. So any questions? This will be recorded, but I would not post this. I will not post this file, right? So at this particular point in time, before you do anything else, right, because if you're working in the classroom already, save your file. And once you save your file, email that to yourself or upload it to Box or somewhere else, right? Otherwise, when you close the Citrix, you will be gone at 12 o'clock midnight today. So save somewhere and email to you right away. So you have a copy of that work. And I'm going to be saving that file so that if somebody asks me later that I have I'll save on desktop. Today is September 14th, right? Okay. So the recording part I'll stop here, right? So that will be the more or less complete tutorial on assignment 7. And I hope that the extra talking is more important because, if I stop, I don't talk anything, I just draw that, I can probably finish up that in about 10 minutes myself. But, the talking help you to understand each one of those difference in notation and how they relate to each other. And hopefully you have unlearned what you learned in ER diagram and get a new way of looking at ER diagram, okay?